Assalamu alaikum wa rahmatullahi wa barakatuhu, and very good morning to all of my dear students. In this video we will see some numericals problem. Look at this on the topic moment of force, okay, or torque. This is also known as torque, moment of force, torque, or turning effect, Okay, now look at this. This one is a scale. The length of the scale is 1 meter or 100 centimeter. Okay, now one fulcrum is put it here at the middle. So this one is 100 centimeter, so fulcrum is put it in at 50 centimeter. Okay, and one load is fixed here. That load, how much? 10 gram force. Okay, one load. Then what happened? Load is fixed at 10 centimeter. So this one is a 0, this one is a 0, and from this 10 centimeter distance, at the 10 centimeter mark, a load is put it. Okay, now from here to here, how much distance? 50 minus 10, 40 centimeter. So from fulcrum at the other end, 40 centimeter, a load is put it. Okay, now this one is a fulcrum pivoted point. At this point, this scale is rotate. So what happen if you put a load here? Then this will be rotate like this. This will be going down. It means it will rotate in anti-clockwise. Okay, simple. Now what is the moment of force? If a force is applied and this distance, simple, moment of force or torque or turning effect is equal to force into perpendicular distance. So this is the force, 10 gram force, and what is the perpendicular distance? From here to here, this is the point of application of force, and from here to here, how much distance? This is the pivot point, and this is the point of application force. Okay, the perpendicular distance. So what is the distance? 40 centimeter. So 10 gram force into 40, multiply this, we get 400 gram force centimeter. Okay, now if this will be in Newton and this will be in meter, the unit will be 400 Newton meter, if it is. Okay, this is also right. Now this answer is not completed. We have to give the direction. In which direction? We know that moment of force or torque is a vector quantity. We have to give the direction. So here, if you force apply here, then the body will rotate like this. Body will rotate anti-clockwise. So this is the answer. You have to write it. The body will rotate anti-clockwise. Clear? Number two is, now this is one same scale. Okay, a load is put at the same distance, 10 centimeter. This is a fulcrum, so this distance is 40. Now here is the question that a W weight is put at 70 centimeter. Okay, to balance this one. Okay, what happen if this is a scale and if you apply a force here, then this scale is rotate like this. So to balance this, we will put a load here. Load in this side. If you put this side, then this will rotate like this. And if you put another force, another weight, then the scale will rotate more. So to balance this one, we will put a load here. Okay, but we don't know at what distance we will put the load. Okay, so we have to find the distance. So here, we know that this distance is no, but we don't know how much weight we will put, how much load we will put to balance this one. Okay, so in this case, we have to find the load. Distance is given at 70 centimeter. A load is put it to balance this 10 kgf. So how much the weight or the load of this one, we have to balance this. Okay, now balance means the horizontal position. The scale will become horizontal or equilibrium condition. This is known as the principle of moment. Okay, now assume that if the load is put it here, then the body will rotate anti-clockwise anti-clockwise, and to balance this one we will put in that direction. Then if you put a load here, then the body will rotate like this clockwise if this one is not there. But since it is a balance, so for balance condition or for equilibrium or horizontal or balance condition, the anti-clockwise moment of force is always equal to the clockwise moment of force. Okay, so remember this one. This is called the principle of moment. This is called the principle of moment. Okay, for balance condition. So the anti-clockwise moment of force is equal to the clockwise moment of force. So we have to calculate the anti-clockwise moment of force and again the clockwise moment of force. Now here look at this. So force is 10 gram force and distance is from the pivot point is 40. So 10 into 40, that is anti-clockwise force, moment of force. And here 70 centimeter a load is fixed, but we don't know how much load is this. So 70 and here 50. So 70 minus 50, what is the difference? 20 centimeter. So 20 into W or W into 20, force is W and 20 is distance. So W into 20. So here all values are given. This 20 will go down. After calculating, we get W equal to 20. So 20 gram force. This W equal to 20 gram force. If you put at 70 centimeter, the distance from this is 20. So this scale will be balanced. Clear? Hope you have understood. Okay. Here one more thing, principle of moment. The concept of principle of moment, we get it. That what is the concept of what is the principle of moment? That anti-clockwise moment of force is equal to the clockwise moment of force to balance. Clear? Here in the third question, same scale. Here mark is 0, here 100 centimeter, 0 to 100. Now one load is fixed at 10 centimeter, another load is fixed at 30 centimeter. Okay, 10 centimeter, 30 centimeter. Then what happened? If you put here 10 centimeter, 30 centimeter, then this will rotate like this. This will rotate like this. Okay, okay. Now we will put 40 gram force here to balance. Again this 10 and 50 will be balanced by 40 gram force. Horizontal condition, equilibrium condition. But we don't know at what distance we will put. This is the weight we have to put it. We have to put it to balance this force here at that direction. Then we will fix here any point. We don't know at what distance we will put. Okay, so let us we will put here the distance from here to here is x centimeter. Okay, now this after putting this load, okay, at x centimeter, this we will assume that this scale is balance or horizontal. Again, if this rod is or this scale is balanced, then it is in equilibrium condition. Then anti-clockwise moment of force is equal to the clockwise moment of force. So look at this. So in that side, two moment of force is acted. So first one is 10 gram force is act. So this 10 gram load is put here. So from here to here, how much distance? From here to here, this distance, how much? 50 minus 10, how much? 40 centimeter. 40 centimeters. So for moment of force at this point, at this force is 10 into 40. So 10 into 40 plus this 50 kg is also put in that direction. So from here to here, 30 and 50. So this distance here will be 20. So this one is a force and this one is a 20. That is the distance. So moment of force at that point will be 50 and this distance 20. 50 into 20. So anti-clockwise moment is this one, and clockwise moment, this 40 GF gram force, 40 and this distance x, that is we have to calculate. We don't know where at what distance we will put. We will calculate. Okay, let us see that this 50, 60, 70, 80, 90, 20, 90 and 100, at what point we will get it. Okay, now this is 40 this 40 and this one, this distance, force into perpendicular distance, 40 into x, 40 into x. Now we know, look at this, calculate this one, 40 into 10, 400, 50 into 20, 1000. This one 40 into x, so 400, 1000, 1400. This 40 will go down. After calculating, we get 35 centimeter. 35 centimeter. So from here to here, how much it is? 35 centimeter. So what point this one? This is not the 35. This just added 50 plus 35. 50 plus 35, 85 centimeter. So this mark is will be 85. At 85 centimeter, we will put this load. Then this rod will be balanced. Hope you have understood. Clear? Anti-clockwise moment is clockwise moment. Okay, clockwise moment of force. So here two moment of forces act, because two forces act at this 40 distance and one is 20. So we calculated 40 into 10 and this one 50 into 20, and here they said 40 into x. After calculating, we get x equal to 35 centimeter. Next one, look at this, number 4. Here this is a same rod, length is 100 centimeter or 1 meter. One force is acts at this point, another force is that acts at this point, but both are opposite. Now look at this. If your force is applied here, in that direction, the body will rotate like this. So this one is a anti-clockwise, and if a force is applied here, then the body will rotate like that. This is also anti-clockwise. So both are anti-clockwise. So the question is, find the total moment of force. Total moment of force. So since the both are anti-clockwise, no one is opposing it. No one is opposing to each other. So both are. We will add this 2 force. Okay, we add this 2 force. Clear? So this is anti-clockwise. So the body will rotate like this. Anti-clockwise. Okay. Now here look at this 10 Newton force. This is a force 1, first one, and this is force 2. At pointing at this one. So from here to here, 0 to 50. 50 minus 0, the distance is 50 centimeter. This one is a 50 centimeter, and this one is also 100 minus 50, 50 centimeter. But here Newton is given. So 50 centimeter. If you convert this one, then 50 by 100, this will become meter. Why meter? Because here Newton is given. Okay. So moment of force at that point is 10 into 50 by 100, or 10 into 50 centimeter, 50 by 100, and moment of force at that point, the total force, same 10 Newton force, that is F2, 10 Newton force, that will be multiplied. Okay, please do correction in your notes. 10 Newton. Okay, and this distance is 50 centimeter. Centimeter will become meter by dividing 100. So this will cancel, this one cancel. We get 5 Newton. Here also 5 Newton. So 5, 10 Newton. Total 10 Newton. So total 10 Newton. So total moment of force is 10 Newton force to rotate this one. If you apply force 10 Newton and 10 Newton. Okay. Clear?